Now that we have a quorum, we'll let our presenters introduce ourselves. First off, Dan Herbert, account executive covering the Carolinas based out of Charleston. I have 18 years of experience working for Dell, VMware, Scale Computing, Arrow, and now Davenport. Very excited to be here talking with you today. With that, Brian, I'll kick it to you.
Hey, good afternoon. My name is Brian Moran, the Director of Solutions Architecture at Davenport Group based in Oklahoma, but I have a team of solutions architects across the country to help you design your next data center solution. I've been with Davenport Group just over 9.5 years, I think, but over 20 years really designing data center solutions. So again, thanks, as Dan said, thanks for joining us today.
Sam, to you.
Hey, good afternoon, everyone. Sam Stevenson. I'm a channel field applications engineer for AMD supporting Davenport Group. That is a very fancy way of saying that I am a channel sales engineer. So happy to be here with y'all. Can't wait to present what we have in store for y'all.
All right, thanks, guys. To note, please come off mute at any time or ask any question, post in the chat as well if you don't want to come off mute. We'll get them answered in real time, and we truly appreciate an interactive crowd. Our main topic today will be AMD and what they can do for you. Before we jump into it, I want to take a minute to give you a quick overview of Davenport Group and why we're having this conversation today. We've always described Davenport Group as a full-scale IT solutions provider, but that's a pretty broad statement. So we've simplified that into essentially four major pillars. The first is infrastructure. This is really the foundation of Davenport Group and what many of you probably know us for today, whether it's the data center, servers and storage, end user devices, networking, or moving workloads to the cloud. Infrastructure continues to be a core part of what we do. The second is cybersecurity. That can range from helping with a specific need like firewalls, endpoint security, education, all the way to helping manage a broader cybersecurity strategy. For organizations that may not have a large internal security team, we can essentially become that team for you. The third is cloud and applications. A simple example would be helping a customer move from on-prem Exchange to Microsoft 365, but our capabilities go well beyond that. We help with cloud migrations, application modernization, the Microsoft ecosystem, and increasingly AI. That includes solutions like Copilot, Copilot Studio, AI assistance, and helping customers figure out where AI can actually provide value within their organization. And the fourth pillar is managed services. This really wraps around everything else. We can fully manage solutions for our customers. We'll work alongside their internal IT teams to co-manage a model project, providing additional expertise and resources where they need them. So when you think about Davenport Group, think about those four areas: infrastructure, cybersecurity, cloud and applications, and managed services. Ultimately, our goal across all four is pretty simple: make business technology simple for our customers. A big part of that is helping our customers evaluate technology based on the business outcomes they're trying to achieve, rather than simply repeating cycles they've always done. And that's what really brings us to today's conversation around AMD. We're seeing AMD become an increasingly compelling option in the data center, particularly as organizations look at performance, core density, power efficiency, and ultimately the overall economics of running their environment. So today isn't simply about looking at AMD as an alternative processor. It's about taking a fresh look at what AMD can potentially do for both the performance and cost of modern data center. And with that, I'll turn it over to Sam to dig into AMD.
Awesome. Thank you very much, Dan. So I just want to preface my presentation with this. Please interrupt me. Do it in the chat. Dan and Brian will keep me honest. They'll raise your questions live. But I really want this to be as interactive as possible. I'm more than happy to monologue at y'all, but these tend to go a lot better when we actually get a little bit of back and forth going. And if you see anything that you want a little bit more clarification on, chances are there are a lot of people on this call that feel the same way. So please feel free to come off chat at any point during this presentation. All right, with that, let's go to the next slide. So first, about AMD, we make a broad array of products. So here is the very limited family portrait. By no means is complete, but you see how we stretch all the way down to our edge and embedded products, up through our very popular Ryzen products in both our client devices. Our Threadripper workstation products are also within Ryzen, up through our server CPUs, EPYC. Radeon has a lovely history as both a consumer GPU, but increasingly, it's being used in workstations and very recently in servers. So you're going to be seeing those on the market a little bit more. And then you get into our big guns when it comes to compute for AI. So our Instinct line is really going to be the king for these last 3 points. Instinct is going to be our first foray into a PCIe format card here. We also have our classic 8-way UBBs still on the market. And then also a new one for us, we have Helios. So that is our first rack scale solution, 72 MI455Xs. This thing is a beast. It is competitive with an NVL 72, and we are using it in deployments against NVL 144s as well. So with that, let's go to the next slide. And I want to talk a lot more about EPYC, because EPYC, our data center CPUs, is really what's on the truck today and what I think we should probably spend most of our time focusing on here. So I'm fairly confident to say that every single one of you on this call has used EPYC in one form or another in the past week. This is because we are absolutely dominant when it comes to hyperscalers and these very, very large service providers that are buying data centers worth of equipment at a time. We've been quite popular here for a while. And if we go to the next slide here, I want to show you that it's not just those hyperscalers. It's small mom and pop shops like Saudi Aramco and Ford. But seriously, we have been able to take our advantages down market. So now it really isn't just, hey, you write your own software and you buy data centers of equipment at a time. Now we've really reached a point where we can bring AMD advantages to every single one of you. If we look at some of these use cases across the top of the slide here, I hope that some of these things jump out at you. I hope that you are looking at your VMware bill and saying, how do I get a little bit of relief here? I hope you're looking at your power efficiency and your power bill climbing, co-locations going to sort of a metered charge model, and you're saying, is there a way to fix this? You're looking at a sprawling old mess of servers and saying it'd be a lot easier to just manage a smaller number here. That would be fewer costs also when it comes to switching. That'd be fewer costs for licensing. That is what we are here to talk about. And ultimately what this comes down to is we offer better performance at a cheaper rate versus our competition. Next slide, please. And this is where we actually are in the market today. So there is a reason why we are not very popular in the market right now. And that's essentially because 7-8 years ago, we were effectively at 0% market share. We're basing this off of x86 server revenue. So this is really just going to be a 2-horse race, us versus Intel. But essentially, we went from 0% to knocking on the door of 50%. This number, 46.2%, is from Q1 of this year. We expect to be crossing 50% either late this year or early next year. So that is some pretty incredible growth. That is some just absolutely meteoric. That is a meteoric rise against a pretty well-beloved brand, which is our competition. Thank you very much. So essentially, I want to explain why this happened. I want to explain that this isn't a fluke, and I want to explain that this isn't a message that should only be received by you if you are running data centers of equipment at a time. A huge portion of this story very much comes down to our OEM presence. So if I was talking to y'all even 3 years ago, we would have a slightly different talk track. It would be a little bit harder to say, hey, go to your OEM of choice and go into one of their maybe 1 or 2 platforms that they have available with AMD. Today, we have broad portfolios from every single one of our OEMs. So it's really not that hard of a choice anymore. It's never been easier to consider AMD, and it's never made more sense, to be frank with you. All right, next slide, please. So part of our advantage comes down to our roadmap. I will say this while trying to not punch down on our dear friends and our competitors in blue, but we have not missed a release date. We have not rolled back products, and I'll find some wood to knock on here. We are going straight into our 6th generation Venice here on time, scheduled. So that is a big differentiator for us. if we go to the next slide, I'll also show you that we're not resting on our laurels either. So we continue to push the boundaries of how many cores can you fit onto a CPU, which is great for some of our customers. But the one that I'm a little bit more excited about is the performance gains. Because what you can see here is performance actually readily outpaces that core count. And where this leaves us is essentially, since our second generation, we have had better per core performance than Intel. And when we get into a licensing conversation and a consolidation play, this allows you to do things with AMD that Intel simply cannot match. And that ultimately is the message here today, is we are ready to meet you regardless of your core count, because we really can fight them at every single level. Whatever SKU that you are familiar with Intel, whatever core counts y'all are currently using, we can match that, and we can boost your performance while keeping the core count static or going down. All right, next slide, please. And then big reminder here. So x86 architecture, there are two companies that sell that on Earth. That is going to be Intel and AMD. And there's a reason for that. AMD actually was the first to market with x86 64-bit. And so essentially what we do is we cross-share our patents with Intel, and that's why there are only two of us. So this is not a crazy uplift. This is not saying, hey, I want you to convert all of your applications to ARM. If you are running it on Intel, chances are it will run on AMD. And when I say chances, I'm saying 99.5% maybe. There are a couple of areas where you may run into problems. So like the first is like SAP HANA running bare metal. Those are only on validated systems, and SAP has not gotten around to validating AMD systems. I bring that up because it is truly the exception, not the norm. There's also this piece on virtualization, where essentially you can't live vMotion from one architecture to another. You can't go from AMD to Intel or Intel to AMD. So effectively, what you need to do is power cycle those VMs in order to do that migration. That is downtime incurred, and hopefully you're robust enough that you can schedule out VM downtime. We actually offer this tool at the bottom right of the slide, our vamped tool. And essentially what this does is it allows you to plan on a VM by VM basis when it will swap over. It validates the swap did happen, and if there are any issues, it will roll it back. And this is fast. In lab settings, we're able to do over 300 VMs per server per hour. So it's a very, 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 very quick process. And the other thing that I'll need to add here is if you are sticking with Intel, if you're going from old Intel to new Intel, while you can live migrate, you are then stuck running your VMs in EVC. You're essentially emulating that older architecture on the new architecture. Major hits to performance, major hits to efficiency, and in order to turn EVC off, you have to, you guessed it, power cycle those VMs. So the cost of upgrading really is some incurred downtime. I am not going to stand in front of you and say that AMD is more convenient here. We are certainly less convenient. But hopefully some of my future slides here will show you why it's worth taking this leap. I'm going to pause here and see if anyone has any questions.
Sam, I might chime in for just a second. I mean, it's been a concern for folks for a very long time about this, fact that you can't live migrate from Intel to AMD. I think you covered it very, very well. For the last year and a half, a lot of the conversations that we've been having have not only been around changing or reconsidering CPU choices, but also hypervisor choices, right? Because I mean, to be frank, Broadcom has really disrupted the market with the way that they have implemented subscription pricing on VMware. On a daily basis, we are having conversations and performing migrations from VMware to Hyper-V or something KVM based or you name it, just because, I mean, while Sam does have some slides that we'll get into around right sizing, VMware environments with efficiencies found in AMD, a lot of people are just leaving VMware altogether. When you go from VMware to like a Hyper-V, for example, that's going to be a reboot anyway. So I think it's a perfect time to introduce this new CPU architecture.
Couldn't agree more. Yeah, if you are moving from VMware to Nutanix, you're incurring downtime. and the tools that you would use to migrate over from Intel Nutanix or Intel VMware to Intel Nutanix, pretty much the exact same tools that you would use to move to AMD on that new platform. So really, if you are considering a move like that, please keep us in mind because it essentially negates all of this negative that I spent some time trying to explain away. The other piece that I'll add here is that we can really work around any licensing scheme. So I will be talking a lot today about VMware for an obvious reason. It's an easy target. It's quite expensive. They've moved to per core licensing. But if you are moving to, say, socket-based licensing, we can also help out there. We can put more cores onto a socket and then have fewer servers overall doing the same amount of work. So AMD is extremely flexible here. Ultimately, we're beholden to y'all as customers. We want to be sure that you have a good experience, and we want to make you return customers. It's not a very good business practice as a CPU manufacturer to essentially just get a lot of bad press with the first people going through the breach. I'll just put it there. Okay, next slide. All right, I want to walk through a couple of rapid fire solutions that AMD can offer, especially while you're looking at a server refresh. So the first is we are heavy in on this strategy to move people to single socket. The reason being is for the majority of workloads out there, a single socket server will do it just fine. I get that I am essentially explaining that I want to cut our sales in half, but bear with me for just a second. So we can fit many, many cores onto a single socket. This generation, we're up to 192 cores per CPU. Next generation, that goes to 256. So in terms of core density, we're already there. For memory, we can offer 12 memory channels per CPU for both our current gen, our 5th generation, as well as our previous generation, our 4th generation. Still in the market, still very competitive. With those 12 memory channels, we can go up to 2 DIMMs per channel, and you can have 24 DIMM slots in one server for a single proc. So that is some pretty massive density right there. For the PCIe lanes and just I/O in general, you do take a hit. With 2 sockets, AMD can currently support up to 160 PCIe lanes. If you go down to 1 socket, you are cutting that number down to 128. So it's a very small decrease. You're only talking about losing 32 potential lanes there. And for that reason, unless you are loading that box up with NICs and accelerators and lots of NVMe drives, a single socket server can really be an interesting route to go down. And here's why you would want to do it. For one, it's cheaper. The platforms are cheaper. The CPUs are also cheaper. If you go for even an R SKU stack from 2 CPUs to 1, there's just a cost efficiency there. But the big reason and why I really, really like pushing it in this day and age is because it's significantly more efficient. So even in our SKU stack, we will do builds where we compare 2 kind of lowish core count CPUs versus 1 higher core count that essentially doubles the performance of that CPU. For some of our high performance SKUs, each one of those 2 smaller core count CPUs consumes the same amount of energy as that single high performance CPU. So the economies of scale there for the power consumption tell a pretty big story unto themselves. And what we find is we can cut down that energy consumption a lot. I actually have a couple cool examples here that we'll get into in a second. And certainly 2 socket does still have a place. If you are trying to put as many accelerators as possible, you have a ton of NICs that you need to put in, we'll typically lean you towards a 2 socket solution. But single socket solution, more energy efficient, more cost efficient. And then the other piece that I'll just mention here, if you've ever dealt with the nightmare of trying to optimize your MPS configuration, you don't need to worry about it with a single socket server. Yeah, with that, next slide. So second point is memory flexibility. So AMD has very, very, very flexible memory interleaving. So any even number of DIMMs per CPU is going to be a balanced configuration for us. This is actually just off of a white paper from Lenovo, I believe. But essentially, what this allows us to do is if you have a current config that you know works for you, you really like your numbers on your memory utilization, we are not going to force you to buy those extra DIMMs. You do take a hit on throughput relative to the maximum possible throughput with us. But typically, when we're comparing us against Xeon, you're in for an upgrade either way. The other thing that I'll mention here is just, yeah, server buying right now is pretty tough. You are essentially buying memory and getting a server for free. That is where costs are with memory sticks. So this can absolutely change the calculus of an AMD build, and I highly, highly, highly recommend just buy what you need. You do not have to fully populate. All right. Next slide. So this one's a little bit of an interesting use case around here. So what we have on this slide is actually a bake-off. We are using our best frenemies GPUs. So we have NVIDIA H100s. These are 8-way systems, retailed for about $250,000 before RAM prices went sideways. And we essentially have the same system with an AMD EPYC processor and with a high-powered Xeon processor from their 5th generation. And essentially what we're showing here is the CPU makes a massive difference in overall system performance. If you are looking at this $250,000 selection or at this $250,000 purchase, and I tell you, hey, you can get 20% more performance out of that, less latency in this case, just by switching that CPU out. With that, you can have 4 servers doing the work of 5. That changes the math. That changes how you approach this. So even though we are talking about a $10,000 CPU, again, within a $250,000 system, it certainly matters. There are a lot of dependencies on the CPU, and this is pretty simple LLM inferencing. This is even more true with agentic workloads. But the CPU certainly does matter, and making sure that you have the right tool for the job really can result in a big step up in overall performance. Next slide, please. And now we get to the true meat and potatoes of the message. And this comes down to the things that I've already said a couple of times, but it's better performance. And when I say that, I'm saying better performance at the CPU level and better performance at the core level, as well as higher efficiency. So this is a pure marketing slide through and through, right? An 8-to-1 reduction. I don't know about any of y'all, but when I was a sysadmin, I would be terrified at the prospect of putting all of my eggs into one basket like this. But it shows you what's possible. This is the top of the SKU stack from Xeon 2nd generation, 24 CPUs, moving to these 192 core parts, the 9965s. So this is what we can do at the high end of our density. By reducing this much, huge power savings, and of course that all-important total cost of ownership. Here we're evaluating it over 3 years. We can reduce that 71% here. But if we go to the next slide, we actually have something a little bit more, probably a little bit more tangible, and that is our 4th generation processors still beat Xeon 6. So this is a much more modest reduction, right? We're going from essentially 15 servers in this middle stack of modern Xeon processors, and we're taking it down to 13. In doing that, we're able to cut the licensing costs significantly. Here by a little bit shy of $400,000 for the 15 server stack. So that is the message that I want to leave y'all with, is to look at the entire picture here. Both us and Intel will look fantastic if you compare us against what is currently in your data center. These older 2nd-gen servers, 3rd-gen, those will absolutely be buried by anything new from Intel and AMD. What I want you to do is, if you are going to take a step, decide which step you want to take. You can go pretty far with Intel, you can go a lot further with AMD. So 4th generation procs from AMD, they are not out of the fight. They are still very much a viable solution here. Next slide. And here we jump back to 5th generation, doing something a little bit more plausible. So we're not doing 1,000 servers, we're looking at a stack of 40 old servers. So as I said, moving to this kind of middle stack, the new Intels, they do a great job. They reduce the server count by half, they reduce the core count by half. It's a really compelling argument to upgrade. But then you have AMD, and we just take it another step further. So we're able to cut down the number of servers from 20 down to 16. Bit easier to manage. The core counts on here are the same. This is a 2 proc to 1 proc story. So by keeping 32 cores per server and reducing the server count, we are able to reduce that core count. So here we're reducing it by a little over 100. VCF MSRP from VMware is about $2,000, a little bit under, like $1,700 per core every 5 years. Every core saved is quite a chunk of change. So if we can prevent y'all from having to expand your core footprint, yeah, the total cost of ownership savings are immense here. And then you get to my favorite piece about the single proc story, which is that power reduction. So I need to stress these blue boxes on the far right here. This is comparing new AMD to new Intel. We don't even bother to compare to the legacy Intel stack in this situation. So if you are looking at a server build, you're thinking about your power bill, you're thinking about your colo's power budget, and you are essentially given the option to reduce it by a third, I would strongly consider that. That will spare you a lot of pain down the road there. Any questions here before I move on? All right, fantastic. Let's go to the next slide, please. And here's the all-important message when you compare Intel to AMD. So pardon the busy slide, but when I worked in the channel community, essentially what I would typically do is I would try to compare two processors by looking at two main numbers. I would look at the core count and I would look at the base frequency. If you take a look at the Intel SKU on the left here versus the AMD SKU on the right, you'll see that these numbers are identical. So you would be forgiven for thinking, oh yeah, these processors probably put up at least similar performance. And while they're, in the same ballpark-ish, they're off by about 30%. And that has some serious impacts on your bottom line. So what we use here, and I want to address this now because it plays into some of the tools that I'll show you in a second here, is we really like this benchmark by spec called Spec Rate. We use the 2017 variant for older servers. There's a new version that we have started using, but the old servers, still most of that data is on 2017. And we're using the integer-based version of that benchmark. This is a very special one for two reasons. One, it is managed by a third party. So this is not AMD, this is not Intel. This is a third party that keeps everyone honest. Results have to be validated by them. It's a fantastic system for an even playing field. And then two is if you are familiar with the Xeon Advisor tool from our friends in blue, if you go into the details about how they are actually comparing stacks of servers, they are actually using this very same benchmark. So we are in a strange spot where us and Intel are in total lockstep about how you assess performance of an old stack of servers versus a new stack of servers. And a benchmark like spec rate integer base for most enterprise applications, they do make a floating point variant as well. But that is going to be the best sort of first pass judgment that we will do on server performance. So us and Intel again in total agreement that this is an excellent benchmark to use. So if we take these two processors in this slide and we go to the next slide here, you'll see how this actually looks when we put it into a server build. So we're looking at 20 servers from Intel. You only need 15 from us to put up the same score. Now, granted, you'd have to buy the same amount of memory over the stack of server and spread it out differently between the servers. Totally fine. But what we're able to do here is we're cutting off essentially 25% of the processors. Remember, these have the same core count per server. So think about that, 25% of your VMware bill or your potential VMware bill gone. think about freeing up that IT budget. That is really what we want to leave y'all with. Is this allows you to do something different than you could do with just a standard refresh, sticking with Intel. Other details on the bottom of the page here, I just want to mention you're cutting off 25% of the servers, but our servers are still more efficient, so you're saving 30% of the power in this configuration. So goes back to that story, and we could obviously push this even further if we went to single proc, but we didn't in this example.
Yeah, and to
So
add here, Sam, we're seeing this across, just as little as 432 servers, right? The cost savings is there for the customer. So we're happy to run these projects with you guys. If there's 1 to 4 servers that you have, up to 20, we can run these projects and examples for you as well. So just wanted to add that.
no, great call out, Dan. Yeah. And then the other thing I want to add is what you're viewing right here. This is actually snippets from AMD's TCO tool. So we have trained Brian's team on this. I am more than happy to walk through this with you in sort of a joint session with members of Brian's team. And we can show you not just a marketing slide, we can show you a good estimate of what your TCO savings look like, what your power reduction looks like. And my favorite part of all of that is we can tweak this. We can customize it. We're not a one-trick pony. If you want massive consolidation, we can go one way. If you want massive energy reduction, we can go another. If you want massive licensing reduction, we'll go a third way. Or we'll find the balance between all three. That is what is possible with this. And that's what we want to bring to your next server refresh. Next slide. We also have a very nice little PDF printout that comes with this tool. So I just took a snip of the top of it here. But essentially, it'll explain our methodology. It'll explain how we got to the numbers that we present to you. And this is absolutely a C-level facing doc. So if you want to bring it to your CIO, CFO, show them, hey, we did our research on this, and here's the path that I think that we can go down. It's a great way to get a little bit of extra credit there.
Yeah, and as Sam said, I mean, my team is ready to help. So we can work with you. Just reach out to your account executive. You'll probably get an email here pretty soon, from just being a part of this event. But we can help analyze, compare what is in your data center now to, a couple of different AMD based options and have this report ready to go, showing, that it does make great financial sense to go ahead and move now.
I appreciate that, Brian.
Hey, Sam, can I make a quick comment? And this goes back to kind of Dan's conversation about calling out smaller environments that maybe have 1 to 4 servers. While maybe the TCO story on a larger scale doesn't make sense, don't forget that with Dell, we have the R4715 and R5715, which are perfectly sized as a starting point for small and medium business, but can also be scaled, and we've seen them work really beautifully in even larger environments. So don't let a smaller environment that might only have a couple of servers derail you or turn you off from looking at a Dell and Epic solution, because they're out there and they are the answer for that small and medium space. And our competitively priced Smart Selection is out there, and they do qualify for my rewards and rebates.
Fantastic. Appreciate that. And the other thing that I'll mention there just comes down to supply. So I don't have a slide on this because this, frankly, could change tomorrow. It's unfortunately the market that we're in. But AMD has been weathering supply constraints significantly better than the other guys. And then what I would just add is when we are in a constrained environment, please look at all options. What I've shown you today, we've covered a lot of ground here pretty quickly, is that essentially we can compete in a couple of different ways. We can use our current generation and we can blow them out of the water, or we can do closer to sort of a one-to-one, sort of modest reductions in power, modest reductions in licensing, reduction in server count with our older generation products. These are going to be less in-demand SKUs. They're going to be different supplies held by the OEMs. So if you are looking to get around a massive price tag, a massive lead time, please consider all options. If we are really in a drought, like why only go to one of the two wells? That's what I would leave you with. We maintain our own supplies with OEMs, and I'll tempt fate by saying this again, we've stayed on top of it significantly better than our competition. All right, next slide, please. All right, with that, I will hand it back over to our friends at Davenport. Thank you all very much for your time.
Thanks, Sam. As Dan hinted at the beginning of the conversation today, Davenport Group does offer a full suite of managed services. It is not kind of one size fits all. It is very custom tailored to fit exactly your needs. So I just wanted to talk through just a couple of examples. So on the co-managed side, what this means is, a lot of the folks that we work with wear multiple hats and don't necessarily have the time or expertise to do things like even major upgrades to critical equipment, right? And so a lot of times I will talk to someone maybe a year after the initial implementation and no updates or patches had been updated, in that year. Scale that out to 3 years, 4 years. I mean, we still talk to a lot of people that happen to be running, vSphere 7 or Windows Server 2012 or various operating systems or versions of code that have reached end of support from, different software or hardware manufacturers. So with our co-managed offering, we have a kind of predictable, proactive schedule where we will help maintain your environment just to make sure that, you are staying current, staying up to date. So we'll have like quarterly health checks, kind of help discuss some of the things that we see that you should prioritize, and then go ahead and also help perform some of those upgrades. On the flip side of that, we work with folks that are in fully managed environments where we use a number of different RMM tools to alert internally us, our team, whenever something needs to be responded to immediately, right? Like let's say a virtual machine disk is getting full, right? So our team is able to, in a fully managed environment, monitor that type of situation and take appropriate reaction before it becomes a problem for you. We have other customers where we fully manage their backup environments, right? And so we're the ones that are ensuring that on a nightly basis, 100% backups are clean and consistent, and even performing restores if and when needed. And there in the middle, advisory services. So on this one, we work with. So just recently, I was on a conversation with a credit union, and the gentleman was recently promoted into a CISO role for regulatory reasons. Right, the credit union grew, and now they have additional audit requirements that they have to maintain. And so this newly promoted CISO had a list of dozens of projects that needed to be completed, but didn't necessarily have the team in place to action any of the priorities. And so what we're able to do is sit down, go through the list, figure out and help them what they can do internally, what we need to help them assist with, and then create things like disaster recovery run books, all the way through, what needs to be done now, like Windows 10 to Windows 11. What can we, do next quarter or next year, and help really maintain that full kind of strategic vision for the direction of the company. And again, this is not one size fits all. We'd like to have a conversation with you, figure out where you are, and how we can just help take some of this work off your plate.
Thanks so much, Brian. We do have one question from Ian. How are you helping customers mitigate rising DDR5 and HBM costs over the next 3 to 5 years?
Yes, that's tough. So first off, when it comes to costs, all three of the memory manufacturers, right? So like Samsung, SK Hynix, Micron have already announced that all of the 2027 supply has been committed and sold. So the problem that we face today is not going to ease anytime in the next 12 months. For customers that have projects that are able to execute sooner rather than later, that is ideal. I know sometimes we have to work with budgeting cycles, right? So maybe you have to submit a budget that doesn't become available until January 1 or July 1 based on your fiscal year. A lot of times whenever we're working with manufacturers, the quotes that we get back are only good for 14 days, maybe 30 days. And so whenever we're trying to budget for projects that are, 6, 12 plus months out, we know that there will be price increases. I mean, it's just kind of the life that we're in right now for the last at least year or so. So that's cost. And so knowing your timeline, we are able to help predict what those costs might be based on today's prices, because I mean, we do have strong relationships with people like Dell, with people like Lenovo that tell us ahead of time whenever price increases are coming. And so whenever you might get an email from one of your account executives that say, hey, act on this now because price increases are coming, that's not just, to pull in an order sooner. I mean, it's the reality that we're in. I mean, if you were to price a server today versus the exact same build that you may have looked at last year, I mean, prices are 2 to 3x at least on different components. As Sam called out before, I mean, it's almost like you are buying memory with a free server that comes with it. So we're doing things like leveraging AMD, where we can have exactly the amount of memory that you need for today, maybe minimal amounts of growth. And AMD gives us that flexibility to right size servers versus putting together like an Intel server. Some of the quoting tools from different manufacturers dictate either 8 DIMMs or 16 DIMMs per CPU with no way around that, right? And so you might only need 384 gigs of RAM. The tool is only going to let you quote 512 when that is the most expensive component in the server itself. I mean, we can save a lot of cost going with AMD in those types of solutions. So that I'm not sure that clarifies, the cost question. The other thing that is a big is lead times, right? So lead times are also all over the place. We see lead times anywhere from 100 days. I mean, that's some of the quoting tools just say 100 days. And what that means is it could quote, or it could ship in a couple months. It could take 6+ months. It's just 100 days is like kind of a placeholder for, we don't know when this is going to ship based on some of the quoting visibility that we have. So Davenport Group does have a strategic partnership with Lenovo. Lenovo has a program called Top Choice Express. We will have another webinar in a few weeks where we will dive into Top Choice Express, but basically what that means is configurable servers that will ship within 2 weeks from order, right? And so instead of placing order now, waiting 6 months to get the order because the NVMe drive or the memory DIMM is on extended lead time, Lenovo had the foresight to pre-buy a lot of capacity specifically to fulfill Top Choice Express orders. And so it's just a special program. There's no additional cost to order from Top Choice. It's just a guarantee that servers ordered via Top Choice Express will ship within a couple of weeks.
Yeah, thanks, Brian.
And
I think
actually,
I'll add
if
as
I can
well.
pile on top of that. Oh, sorry.
Go ahead, Sam.
Yeah, so I just want to add what we're doing to address this as well. I mean, this is extremely painful for AMD because obviously we can't sell our CPUs without selling memory, and playing second fiddle is not a very fun place to be. If anyone has any ideas for how to sell CPUs without memory, give me a call. I'm thinking very expensive drink coasters or something like that. But essentially, what we're doing is we are pursuing technologies to optimize the amount of memory purchase. So having a smaller amount of memory appear to be a larger memory footprint than it actually is. I can't go into too many details on this, but we just announced publicly that we acquired MEXT, M-E-X-T. You're going to see AMD pursuing a lot of technologies like this to drive down that cost, in addition to our general value add, trying to offset those costs there. The other common sense thing that I would just add to plug the Davenport team here, taking a serious look at your consumptions, running live optics, and really making sure that you are getting the right amount of memory for the job, rather than just sort of hitting the refresh button. That is absolutely crucial. So I can't overstate how important it is to work with them, hopefully us as well, to figure out what is the most cost-effective solution at your next server refresh.
Yep, thanks so much, Sam. And to add another thing from a Davenport perspective, we do have a tool that we can essentially model out what cost would be this month versus October to next year. So kind of from what we're hearing from Dell, Lenovo, all our other partners on what they anticipate prices rising to. So we're happy to run those projects for you as well and utilize that tool to give you a best case of what it's going to cost today versus 3, 6, 9, 12 months from now. Hopefully that helps answer that question, Ian. With that, next slide, Kylie. Any other questions from anyone else? Thanks so much, Ian, for that. All right, we will move on to the fun stuff. So if this is of any interest of anybody on the calls, please reach out to us, your account executive, anyone here at Davenport. We're happy to bring in AMD, have more in-depth conversations with our SAs, Brian's team, anything about our services. If you do want to take a meeting, we'll send you a gift card of $50 for your Lowe's or Home Depot. We also do have, I wanted to mention, a client sales executive that would be focused on our client and user side of the house. It would be AMD focused as well. I know a lot of today was on infrastructure, but wanted to kind of bring that up. Again, just wanted to thank you for the gift card, and for the next 2 slides will be really fun. Whoever wanted an Arctic soft-sided cooler will ship that in the next 3 to 5 days, and Grubhub, that'll come in the next 3 days. So truly appreciate everyone's time today. All the questions that we had, the teammates here at AMD. Just a quick thank you again for Sam, his team, and Brian. We're appreciative of everyone on the call. We know your time is valuable and appreciate you spending it with us today. If you have any questions, please reach out to myself or your other account executives, and we're happy to go further. With that, I will end it.